Picture, if you will, the Earth 500 million years ago. The continents we know today existed only as scattered fragments, and vast oceans stretched across a world that would seem utterly alien to our eyes. Yet in those ancient waters, something remarkable was beginning to stir. The first chapter of one of nature's most extraordinary stories was about to unfold. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. In the warm, shallow seas of the Cambrian period, life was experimenting with forms that would make even the most imaginative science fiction seem mundane. These were waters populated by creatures that wore their homes as armor, magnificent spiral shells that coiled like ancient staircases, each chamber a monument to growth and survival. The nautiloids, as we call them now, were among Earth's first great mariners, jet-propelling themselves through prehistoric oceans with primitive elegance. Consider for a moment the audacity of their design. These early cephalopods had discovered something that would not be reinvented until humans learned to build rockets, the principle of jet propulsion. By forcibly expelling seawater through specialized funnels, they could navigate their liquid world with purposeful grace. Their shells, some reaching lengths of 15 feet, served as both fortress and flotation device, perfectly calibrated to maintain neutral buoyancy in the ancient seas. But evolution, as we know, rarely settles for a single solution. While some cephalopods continued perfecting their shelled existence, others began to experiment with something far more radical. Around 300 million years ago, in what paleontologists now recognize as one of the most daring evolutionary leaps in Earth's history, some of these creatures made an extraordinary choice. They abandoned their shells entirely. Imagine the courage, if we may call it that, required for such a transformation. These ancestral octopuses traded the security of armored protection for something infinitely more valuable: freedom. Without the weight and bulk of heavy shells constraining them, they discovered movement possibilities that their armored relatives could never achieve. Their bodies became liquid architecture, capable of flowing like water through the smallest gaps, transforming their very shape to navigate the complex three-dimensional maze of coral reefs and rocky crevices. This transition represents nothing less than evolution's boldest experiment in underwater living. The soft-bodied octopuses that emerged from this transformation possessed something their shell-bearing ancestors could never claim: the ability to become invisible. Their boneless forms could squeeze through any opening larger than their beak, the single hard structure they retained. They could flatten themselves against rocks, flow between coral branches, and disappear into spaces that seemed impossibly small. The physics of their transformation is breathtaking in its elegance. Where shells had once provided protection through rigid strength, these new creatures found safety in adaptability. The crushing pressure of deep water, which would destroy most air-breathing life, became their ally. Their tissue-based bodies, being largely incompressible, could descend to depths reaching 6,000 meters below the surface, deeper than Mount McKinley is tall, without suffering the structural damage that would cripple creatures dependent on air-filled spaces. But perhaps the most remarkable aspect of this evolutionary journey was what happened to their minds. As their bodies became more flexible, their nervous systems grew increasingly sophisticated. The simple ganglia that had served their shelled ancestors began expanding into something unprecedented in the invertebrate world: distributed intelligence, networks that would eventually rival the cognitive capabilities of vertebrates. Ancient human civilizations, when they first encountered these creatures, sensed immediately that they were in the presence of something otherworldly. Greek sailors, those master navigators who mapped the Mediterranean with remarkable precision, spoke in hushed, reverent tones about the many armed beings that emerged from the depths. They told stories around flickering fires of creatures that seemed to think, to plan, to possess an intelligence that felt disturbingly familiar, yet utterly alien. The legendary kraken of Nordic folklore, with arms described as reaching 100 feet across, represents humanity's first attempt to grapple with the reality of octopus intelligence. These were not merely stories of sea monsters, but rather the earliest recorded recognition that the ocean harbored minds that had evolved along completely different pathways than our own. The Vikings, those fearless explorers who crossed the Atlantic in open boats, reserved their deepest respect for these many-armed guardians of the deep. What those ancient storytellers could not have known was that they were describing the outcome of one of evolution's most successful experiments in consciousness. The octopus mind that so captivated early human imagination represented a form of intelligence that had developed in complete isolation from the vertebrate line that would eventually produce our own species. Here was proof that consciousness, that most precious and mysterious of phenomena, was not unique to creatures with backbones. The fossil record, though frustratingly incomplete due to the soft-bodied nature of these creatures, tells us that the transition from shelled to shell-less cephalopods occurred gradually over millions of years. Some species retained partial shells, others developed internal support structures, while still others abandoned hard parts entirely. This was evolution in real time, testing different solutions to the fundamental challenge of underwater survival. As we trace this ancient lineage forward through time, we begin to see the emergence of characteristics that would define octopus success for hundreds of millions of years. Their skin developed the ability to change color and texture with stunning rapidity, a capability that would make them masters of disguise. Their arms evolved into something far more sophisticated than simple appendages, becoming extensions of their minds capable of independent thought and action. The waters they inhabited were themselves undergoing dramatic transformations. Ocean chemistry fluctuated as atmospheric conditions changed. Sea levels rose and fell with the rhythms of ice ages and geological upheavals. Continents drifted across the globe, creating new ocean basins and closing ancient seaways. Through all these changes, the octopus lineage persevered, adapting and evolving with each environmental challenge. Perhaps most remarkably, as their bodies became more sophisticated, their behaviors grew increasingly complex. They learned to use tools, to solve problems, to recognize individuals, and to engage in what can only be described as play. They developed personalities as distinct as those of any mammal, with some individuals proving bold and exploratory while others remained cautious and observant. The ancient seas that birthed these remarkable creatures were places of endless possibility. In those primordial waters, life was writing the first chapters of stories that continue to unfold today. Every octopus we encounter in our modern oceans carries within its genes the memory of that original evolutionary leap, the moment when some ancestral cephalopods chose adaptation over protection, flexibility over strength, intelligence over armor. As night falls over our contemporary seas and moonlight dances on the waves, millions of octopuses continue the ancient ritual of emergence from their dens. They flow through the underwater landscape like living poetry, their 8 arms exploring every crevice and surface with curiosity that spans geological ages. In their graceful movements, we can see echoes of their incredible journey from armored mariners to soft-bodied masters of the deep. The story that began 500 million years ago in those ancient seas continues to unfold in every tidal pool, every coral reef, every deep ocean trench where octopuses make their homes. They remind us that intelligence comes in forms we are only beginning to understand, that consciousness may be far more widespread in the natural world than we ever imagined, and that the ocean still holds secrets that could fundamentally change how we view life on Earth. Tomorrow, we will explore how those ancient foundations gave rise to something even more extraordinary, the evolution of the octopus into nature's most sophisticated marine intelligence. But for now, as you drift towards sleep, imagine those first shell-less cephalopods moving through moonlit waters, their soft bodies pulsing with the rhythms of the tide, their minds just beginning to discover the vast possibilities that lay ahead in their remarkable evolutionary journey. 200 million years is a span of time that challenges human comprehension. To put this in perspective, imagine compressing the entire history of human civilization into a single day, from the first agricultural settlements to our modern world. The evolutionary refinement of the octopus mind would represent not days, not months, but decades of such compressed time. This is the scale on which nature operated to craft what may be the ocean's most sophisticated intelligence. As we journey forward from those ancient shell-abandoning pioneers, we witness evolution working with the patience of geological time and the precision of a master craftsman. Each generation of octopuses carried forward the genetic wisdom of their ancestors while adding new innovations, new solutions to the endless challenges of underwater survival. The result, emerging slowly across eons, would be a creature so perfectly adapted to its environment that it seems almost magical in its capabilities. Consider the extraordinary architecture of the octopus nervous system. While our own intelligence is centralized in a single brain weighing approximately 3 pounds, evolution took an entirely different approach with octopuses. Their 500 million neurons, more than many mammals possess, are distributed throughout their body in a network so sophisticated that each arm can be considered a semi-independent thinking entity. Imagine having 8 different minds working in harmony with your central consciousness. Each octopus arm contains 65 million neurons, more processing power than exists in the entire head of most mammals. These neural networks allow each arm to explore, taste, and react independently while remaining coordinated with the creature's overall intentions. It is biological engineering on a scale that makes our most advanced computers seem crude by comparison. This distributed intelligence represents one of evolution's most elegant solutions to the challenge of processing vast amounts of sensory information simultaneously. While you and I must focus our attention sequentially, looking here, then there, thinking about one thing and then another, an octopus can literally think with its entire body. One arm might be exploring a crevice for hidden prey, while another tests the texture of a nearby rock, and a third investigates an unusual scent carried on the current. The sensory capabilities that evolved alongside this distributed nervous system are nothing short of extraordinary. Each of those 8 arms is covered with thousands of suction cups, and each suction cup contains both taste and touch receptors. When an octopus explores its environment, it is simultaneously tasting and feeling everything it encounters. Imagine being able to taste the surface of everything you touch. The overwhelming richness of sensory information would be difficult for our centralized minds to process. Yet octopuses handle this constant flood of data with effortless grace. But perhaps the most visually stunning of all octopus capabilities is their mastery over color and pattern. Their skin became evolution's most sophisticated display system, capable of transformations that make our most advanced digital screens appear primitive. The mechanism behind this remarkable ability involves 3 distinct types of specialized cells working in perfect coordination. The chromatophores, containing granules of red, yellow, and brown pigments, form the foundation of this living canvas. Each chromatophore is surrounded by tiny muscle fibers that can contract in milliseconds, causing the pigment granules to spread across the cell like ink dispersing in water. When the muscles relax, the granules cluster together, and the color virtually disappears. An octopus can activate thousands of these cells independently, creating patterns of infinite complexity. Beneath the chromatophores lie the iridophores, cells that work like biological mirrors. These contain stacks of reflective plates that can be adjusted to bounce back specific wavelengths of light, creating the shimmering silvers, golds, and blues that seem to flow across an octopus's skin like liquid metal. The effect is so convincing that diving photographers often struggle to distinguish between an octopus and the coral it's mimicking. The deepest layer consists of leucophores, cells that scatter light to produce white and pale colors. Working together, These three systems can generate virtually any color or pattern found in the natural world. The octopus becomes a living mood ring, its skin reflecting not only its surroundings but also its emotional state and intentions. The speed of these transformations defies belief. An octopus can shift from perfect coral mimicry to sandy bottom camouflage in less than 3/10 of a second, faster than the human eye can track. This ability serves multiple purposes: hiding from predators, ambushing prey, and communicating with other octopuses through a visual language more complex than many human sign systems. But color change represents only one aspect of the octopus's mastery of disguise. Their skin can also alter its texture with equal rapidity. Specialized muscle fibers can create bumps, ridges, and projections that perfectly match the surface they're resting against. An octopus settling onto a coral reef doesn't merely change color to match the coral. It sculpts its skin to replicate the coral's three-dimensional structure. The transformation is so complete that even experienced marine biologists can swim past an octopus without noticing its presence. The evolution of their propulsion system demonstrates nature's talent for elegant engineering solutions. The octopus siphon, a muscular funnel that can be aimed in any direction, transforms water into a medium of rapid transportation. By filling their mantle cavity with water and then forcibly expelling it through the siphon, octopuses achieve instant acceleration that would be the envy of any submarine designer. This biological jet engine allows them to accelerate from complete stillness to 25 miles per hour in mere seconds. The system is remarkably efficient, requiring no external fuel source and producing no waste products. When an octopus needs to escape danger, it simply aims its siphon in the opposite direction and rockets away in a cloud of water and sometimes ink, disappearing before most predators can react. The hydrodynamics involved in octopus locomotion reveal yet another layer of evolutionary sophistication. Their bodies can shift from the rigid, streamlined form needed for jet propulsion to the flexible, flowing shape required for crawling across complex surfaces. No human-designed vehicle possesses such adaptability. Imagine a car that could instantly transform into a helicopter, then reshape itself into a submarine as circumstances demanded. As these remarkable capabilities were evolving, octopuses were also developing cognitive abilities that would eventually rival those of dolphins and primates. Their problem-solving skills emerged from the combination of their distributed nervous system, their incredibly sensitive tactile abilities, and their need to navigate an environment of endless complexity. The octopus brain processes information in ways that continue to puzzle neuroscientists. Unlike human brains, which rely heavily on vision and symbolic processing, octopus cognition appears to be primarily tactile and spatial. They think with their arms as much as with their brains, creating a form of embodied intelligence that challenges our understanding of consciousness itself. Recent research has revealed that octopuses possess something that neuroscientists call episodic-like memory, the ability to remember not just what happened, but when and where it happened. This cognitive capability, once thought to be unique to humans and a few other species, allows octopuses to learn from experience in sophisticated ways and to plan for future events based on past outcomes. Their learning abilities continue to astonish researchers. Octopuses can solve complex mazes, learn to navigate through tubes and passages, and even figure out how to open sequential locks to reach food rewards. What makes these achievements even more remarkable is that octopuses accomplish these feats without the social learning that aids problem-solving in many other intelligent species. Each octopus must essentially reinvent solutions to common problems, yet they do so with consistency that suggests underlying cognitive principles similar to those found in much more social creatures. The evolution of octopus intelligence appears to have been driven by the demands of their predatory lifestyle and the complexity of their environment. Coral reefs, kelp forests, and rocky shorelines present three-dimensional puzzles that change with every tide. Success in such environments requires not just physical adaptability, but also the cognitive flexibility to recognize patterns, remember locations, and adapt strategies based on changing circumstances. As night falls across the modern ocean, millions of octopuses emerge from their dens to begin the ancient ritual of the hunt. Each carries within its distributed nervous system 200 million years of evolutionary refinement, neural networks that can process information, solve problems, and adapt to challenges with a sophistication that rivals any creature in the sea. Their 8 arms flow through the water with purposeful grace, each one a living extension of a mind that represents one of evolution's most successful experiments in intelligence. In the gentle rhythm of their movements, we can see the culmination of countless generations of gradual improvement, each octopus a testament to the patience and creativity of evolutionary processes. Tomorrow, we will follow these remarkable creatures through their daily lives, witnessing firsthand how their extraordinary adaptations translate into survival strategies that have proved successful for hundreds of millions of years. But tonight, as you drift towards sleep, imagine the quiet intelligence flowing through darkened waters, 8-armed minds thinking thoughts we are only beginning to understand, carrying forward the ancient wisdom encoded in their remarkable nervous systems. Dawn breaks over the coral reef with the gentlest of transformations. Light filters down through layers of seawater, painting everything in shifting patterns of blue and gold. As the first rays penetrate the depths, a subtle movement catches the eye, or rather, it would catch the eye if you could see it. An octopus, perfectly camouflaged, against the coral it calls home, begins to stir from its nocturnal rest. This daily awakening represents the beginning of one of nature's most sophisticated behavioral repertoires. The octopus doesn't simply wake up and begin searching for food in the random manner we might expect from a simple predator. Instead, it conducts what can only be described as a morning reconnaissance, using its 8 arms to systematically explore the territory around its den, while its remarkable eyes scan for opportunities and threats. Watch carefully as this master of the liquid world begins its day. Each arm moves with deliberate purpose, testing water currents for chemical traces that might indicate nearby prey, feeling along familiar surfaces for changes that might signal new hiding spots or potential dangers. The octopus is reading its environment like we might read a morning newspaper, gathering information that will inform every decision it makes throughout the coming day. The hunting strategies employed by octopuses reveal intelligence that operates on multiple levels simultaneously. Consider a common octopus stalking a crab across the sandy bottom of a shallow bay. This is not a simple chase between predator and prey. It is a complex problem-solving exercise that demonstrates spatial reasoning, timing, and strategic planning that would impress any military tactician. The octopus approaches from the crab's blind spot, moving with movements so subtle they barely disturb the sand beneath its arms. It times its advances with the surge of waves overhead, using the natural rhythm of the ocean to mask its approach. When the water pushes landward, the octopus freezes, becoming indistinguishable from the rocks and debris scattered across the seafloor. When the water pulls seaward, it advances, flowing like liquid shadow across the bottom. But the truly remarkable aspect of this hunt lies in the octopus's ability to predict the crab's likely escape routes. Crabs don't flee randomly when threatened. They follow predictable patterns based on the topography around them and their own physical limitations. The octopus appears to understand these patterns, positioning its arms not where the crab is, but where the crab will be once it begins its escape attempt. When the moment of capture arrives, the strike happens with lightning precision that seems almost supernatural. Multiple arms extend simultaneously, creating a living net that intercepts the crab's escape routes before the prey even realizes it's been detected. The coordination required for such a maneuver challenges our understanding of how distributed nervous systems can achieve such unified action. Once captured, the octopus employs its powerful beak, the only hard structure in its otherwise soft body, to crack through the crab's shell with surgical precision. This beak, composed of the same material that forms our fingernails but engineered to perfection by evolution, can exert tremendous force while maintaining the delicate control necessary to extract meat without damaging the valuable nutrients within. The tool use that has been observed among octopuses represents perhaps the most startling evidence of their intelligence. In the shallow waters of Indonesia, researchers have documented octopuses collecting discarded coconut shell halves, carrying them across considerable distances, and then assembling them into portable shelters when the need arises. This behavior requires not only the ability to recognize useful materials, but also the capacity for forward planning that was once thought to be uniquely human. The process is as methodical as it is remarkable. An octopus will examine a coconut shell carefully, testing its structural integrity and size before deciding whether to invest the considerable energy required to transport it. The shells must be carried awkwardly, held beneath the octopus's body while it walks across the seafloor on the tips of its arms. This ungainly locomotion makes the octopus more vulnerable to predators and significantly slows its movement, yet they persist with their cargo collection because they understand its future value. When the time comes to use these portable shelters, the octopus demonstrates engineering skills that would do credit to any architect. The two shell halves are manipulated with precision, fitted together to create a nearly perfect sphere with the octopus safely enclosed inside. The joining is so seamless that the assembled shelter appears to be a natural coconut rather than an artificial construction created by an invertebrate engineer. Other tool use behaviors reveal the diversity of octopus problem-solving abilities. Some species collect rocks and arrange them into protective barriers around their dens, creating sophisticated fortifications that can be reconfigured as threats change. Others have been observed using discarded bottles and cans as mobile homes, demonstrating remarkable adaptability to human-altered environments. The color-changing capabilities that we explored in the previous chapter take on new meaning when observed in the context of daily survival. An octopus doesn't simply change colors to blend with its surroundings. It creates artistic masterpieces that serve multiple functions simultaneously. When hunting, the subtle earth tones and flowing patterns help it become invisible to prey. When threatened, rapid flashes of warning colors communicate danger to potential predators. During social encounters, complex sequences of patterns and hues convey intentions and emotional states with a sophistication that rivals human facial expressions. Perhaps most remarkably, octopuses appear to experience emotions in ways that we are only beginning to understand. Their color changes often reflect internal states that have no immediate survival function, the aquatic equivalent of blushing, frowning, or smiling. A curious octopus investigating a new object displays flowing patterns of soft colors that seem to reflect wonder and interest. An angry octopus shows dramatic contrasts of dark and light that leave no doubt about its emotional state. The social interactions of octopuses challenge long-held assumptions about solitary creatures. While they don't form the complex societies we see in dolphins or primates, octopuses demonstrate surprisingly sophisticated awareness of other individuals. They can recognize specific humans, responding differently to familiar and unfamiliar people even after months of separation. This recognition appears to be based not just on visual cues, but also on behavioral patterns and perhaps even individual scents. During mating season, male octopuses perform elaborate courtship displays that can last for hours. These performances involve coordinated changes in color, pattern, and body posture that create living art more beautiful than anything in human galleries. The males demonstrate both physical prowess and artistic creativity, suggesting that aesthetic appreciation may be more widespread in the animal kingdom than we previously imagined. The daily rhythm of octopus life follows patterns that seem almost meditative in their regularity. As daylight fades and evening approaches, these primarily nocturnal creatures begin their most active period. They emerge from their dens with movements that flow like underwater ballet, their arms exploring every surface within reach while their large eyes scan constantly for movement in the darkening water. Night hunting reveals different aspects of octopus intelligence. In the reduced visibility of darkness, they rely more heavily on their sense of touch and their ability to detect chemical traces in the water. Their arms become extensions of their consciousness, reaching into crevices and gaps where prey might hide, tasting and feeling their way through a three-dimensional maze of possibilities. The problem-solving abilities that octopuses display during their daily activities continue to astonish researchers. They can learn to navigate complex mazes, figure out how to open sequential locks, and even solve puzzles that require multiple steps completed in specific sequences. What makes these achievements particularly remarkable is that each octopus must learn these skills independently. They don't benefit from the social learning that helps other intelligent species acquire complex behaviors. As the night deepens and the ocean settles into its quieter rhythms, octopuses continue their ancient dance of survival and exploration. Their movements through the water carry the grace of creatures perfectly adapted to their environment, every gesture efficient and purposeful, yet somehow artistic in its execution. In tide pools around the world, smaller octopus species conduct their own versions of this daily drama on a more intimate scale. These miniature masters of camouflage navigate worlds measured in inches rather than miles, yet they display the same intelligence, the same problem-solving abilities, and the same remarkable adaptability as their larger relatives in deeper waters. The gentle rhythm of their lives speaks to something profound about the nature of intelligence itself. These creatures have evolved to live in harmony with their environment rather than attempting to dominate it. Their success comes not from overwhelming force or rigid hierarchy, but from flexibility, creativity, and the ability to adapt to whatever challenges each day might bring. As you settle into sleep tonight, imagine the peaceful ballet continuing in darkened waters around the world. Millions of octopuses flowing through their liquid realm, each one a masterpiece of evolutionary engineering, each one carrying forward the ancient wisdom of adaptation and intelligence that has served their kind for hundreds of millions of years. Imagine standing at the edge of the ocean and contemplating the vast realm that stretches before you. From the sun-warmed shallows where waves gently lap against the shore to the crushing depths where no sunlight has ever penetrated, every cubic meter of seawater represents potential habitat for life. In this three-dimensional wilderness, spanning from surface to seafloor across all the world's oceans, 300 different species of octopuses have found their perfect homes. Each species represents evolution's solution to a specific set of environmental challenges. Like artists working with the same basic materials but creating wildly different masterpieces, these octopuses have adapted the fundamental eight-armed body plan to thrive in environments so diverse they might as well be different planets. From tropical coral gardens to polar seas, from shallow tide pools to abyssal plains, deeper than Mount Everest is tall, octopuses have claimed every conceivable marine habitat as their own. Let us begin our journey through this diverse kingdom with perhaps the most magnificent of all octopus species, the giant Pacific octopus. In the cold, nutrient-rich waters of the North Pacific, these gentle titans roam territories that can span several miles. With arms reaching 30 feet from tip to tip and weighing up to 600 pounds, they are living legends of the deep creatures so large they challenge our preconceptions about invertebrate life. Yet for all their impressive size, giant Pacific octopuses remain remarkably gentle creatures. Divers who encounter them in their rocky dens often describe experiences that feel more like meetings with wise elders than confrontations with monsters. These enormous beings will often allow humans to approach, extending massive arms in what appears to be curiosity rather than aggression. Their skin, flowing with colors that shift like aurora across their vast surfaces, seems to reflect an intelligence as deep as the waters they call home. The longevity of giant Pacific octopuses sets them apart from their smaller, Relatives. While most octopus species live for only 1 or 2 years, these giants can survive for 5 years or more, giving them time to accumulate knowledge and experience that smaller species never achieve. Aquarium workers who care for giant Pacific octopuses often speak of their distinct personalities, their apparent ability to recognize individual humans, and their sophisticated problem-solving abilities that seem to improve with age. Their intelligence manifests in remarkable ways. Giant Pacific octopuses have been observed opening child-proof bottles, solving complex mazes that would challenge laboratory animals, and demonstrating memory capabilities that span months or even years. Some individuals appear to enjoy tactile games, manipulating objects for no apparent purpose other than the satisfaction of exploring new textures and movements. At the opposite extreme of the size spectrum, we encounter one of nature's most beautiful and dangerous creations, the blue-ringed octopus. These jewel-like creatures, measuring only 8 inches from armtip to armtip, inhabit the warm waters of the Indo-Pacific with an elegance that belies their lethal capabilities. When threatened, their skin transforms into a living warning signal, brilliant blue rings pulsing across a golden background in patterns so hypnotically beautiful they seem almost designed to attract rather than repel. This extraordinary display serves as nature's most honest advertisement. The blue-ringed octopus carries within its tiny body enough venom to kill 26 adult humans within minutes. The toxin, more potent than that of any snake or spider, causes rapid paralysis while leaving the victim conscious and aware. Yet these remarkable creatures use their deadly gift only as a last resort, preferring to rely on their camouflage abilities to avoid confrontation entirely. The venom itself represents a masterpiece of biochemical engineering. Produced by specialized bacteria living symbiotically within the octopus's body, it blocks the transmission of nerve signals with surgical precision. This partnership between octopus and bacteria demonstrates the collaborative nature of evolution, showing how different forms of life can work together to create capabilities that neither could achieve alone. In the crushing darkness of the deep ocean, 4 miles below the surface where pressure exceeds 800 times that at sea level, we find perhaps the most endearing of all octopuses, the Dumbo octopus. Named for their ear-like fins that flutter as they move through the water, these ethereal creatures drift through the abyss like underwater angels, their translucent bodies pulsing with bioluminescent displays that create moving constellations in the eternal night. The environment they call home would be instantly fatal to most surface dwellers. Temperatures hover just above freezing, pressure would crush any air-filled structure in milliseconds, and food is so scarce that every meal becomes a precious gift. Yet Dumbo octopuses have not merely survived in these extreme conditions, they have flourished, developing specialized adaptations that allow them to thrive in Earth's most challenging marine environment. Their fins, unique among octopuses, provide them with precise control over their movement through the water column. Unlike their shallow water relatives who rely primarily on jet propulsion, Dumbo octopuses swim with a grace that seems almost supernatural, adjusting their buoyancy and direction with subtle movements of their translucent fins. They can hover motionless in the current, rise and fall through the water column with perfect control, and navigate through underwater landscapes invisible to surface dwellers. The feeding strategies of deep-sea octopuses reveal remarkable adaptations to life in the food-poor depths. They have evolved to consume prey that would be ignored by shallow-water species, tiny crustaceans, marine, worms, and other small creatures that drift down from the productive waters above. Their digestive systems have become incredibly efficient, capable of extracting every possible nutrient from their scarce meals. In the warm, coral-rich waters of Southeast Asia, we encounter one of nature's greatest performance artists, the mimic octopus. This Indonesian master of disguise has elevated camouflage from simple background matching to sophisticated behavioral mimicry that includes not just appearance but also movement patterns and behavioral cues. A single mimic octopus can impersonate flatfish, lionfish, stingrays, sea snakes, and dozens of other marine creatures with such accuracy that even experienced marine biologists can be fooled. The transformations happen with startling speed. One moment you might be observing what appears to be a flounder gliding across the sandy bottom, its movements perfectly matching the undulating swimming style of a flatfish. Seconds later, the same creature rears up to display the bold stripes and flowing fins of a lionfish, complete with the characteristic fanning movements that warn potential predators of venomous spines. This behavioral mimicry requires not just physical adaptability, but also detailed knowledge of other species' behaviors. The mimic octopus must understand how different creatures move, how they respond to threats, and how they interact with their environment. This suggests a level of observational learning and behavioral flexibility that rivals that of the most intelligent vertebrates. The coral reef ecosystems, where many octopus species make their homes, represent some of the most complex and diverse environments on Earth. Here, competition for food and shelter is intense, predation pressure is constant, and the three-dimensional structure of the reef creates an almost infinite variety of microhabitats. Success in such an environment requires not just physical adaptations but also behavioral flexibility and intelligence. Reef-dwelling octopuses have evolved an astonishing array of survival strategies. Some species specialize in hunting during the brightest part of the day, using their superior camouflage abilities to ambush prey that feel safe in broad daylight. Others emerge only during the darkest nights, relying on their enhanced tactile abilities to navigate and hunt in complete darkness. The smaller octopus species that inhabit tide pools and shallow coastal waters face their own unique challenges. These miniature environments can change dramatically with each tide cycle, transforming from complex underwater gardens to exposed rocky surfaces in a matter of hours. The octopuses that call these places home must be able to survive, both underwater and in air, finding secure hiding spots that will protect them during low tide periods. These intertidal octopuses have developed remarkable physiological adaptations that allow them to survive temporary exposure to air. They can slow their metabolism dramatically, reducing their oxygen requirements while their gills remain moist enough to continue extracting oxygen from the thin film of water they retain. Some species can survive out of water for several hours, hiding in damp crevices until the returning tide restores their aquatic environment. The Arctic and Antarctic oceans present yet another set of challenges for octopus survival. In these polar waters, temperatures remain near freezing year-round. Ice forms and melts with seasonal regularity, and the extreme variations in daylight create environments that shift dramatically between continuous summer sun and winter darkness. The octopuses that thrive in these harsh conditions have evolved specialized adaptations that allow them to function efficiently in near-freezing water. Their blood contains antifreeze proteins that prevent ice crystal formation. Their metabolisms have slowed to match the reduced pace of polar ecosystems, and their behaviors have adapted to the extreme seasonal variations in food availability. Some polar octopus species enter states of reduced activity during the harshest winter months, essentially hibernating until conditions improve. As we survey this remarkable diversity of octopus life, from the giants of temperate seas to the jewel-like inhabitants of tropical reefs, from the ethereal angels of the deep ocean to the hardy survivors of polar waters, we begin to appreciate the extraordinary adaptability that has allowed these creatures to colonize virtually every marine environment on Earth. Each species tells a story of evolutionary innovation, of life finding ways to thrive in conditions that might seem impossible. Together, they represent one of evolution's greatest success stories, a basic body plan so flexible and a nervous system so adaptable that they could be modified to meet the challenges of any environment the ocean could provide. Tonight, as you drift towards sleep, imagine this vast community of 8-armed inhabitants going about their nightly routines in waters around the world. From the smallest tide pool octopus exploring its miniature domain to the largest giant drifting through kelp forests like a living cloud, each one continues the ancient story of adaptation and survival that has made octopuses one of the ocean's most successful families. For most of human history, the octopus remained an enigma wrapped in mythology and fear. Sailors spoke of them in whispers, artists depicted them as monsters, and even the earliest naturalists struggled to understand creatures that seemed to defy every assumption about animal intelligence. The journey from fear to wonder, from mythology to scientific understanding, represents one of the most remarkable shifts in human perception of the natural world. The transformation began quietly, in the sterile environment of a laboratory in Plymouth, England, in the year 1959. A young British zoologist named Martin Wells was conducting what seemed like routine experiments on learning and memory in marine animals. He had chosen octopuses almost by accident. They were readily available from local fishermen, hardy enough to survive in laboratory conditions and large enough to work with easily. What Wells discovered would forever change how we think about intelligence in the ocean. Wells constructed simple mazes and presented octopuses with basic problem-solving tasks, expecting to document the simple reflexes and instinctual behaviors typical of invertebrates. Instead, he found himself face to face with minds that seemed to approach problems with deliberate thought and careful analysis. The octopuses in his experiments didn't just stumble through trials until they accidentally found solutions. They appeared to study the challenges before them, test different approaches, and remember successful strategies from one trial to the next. Most remarkably, they solved complex mazes faster than laboratory rats, animals that had long been considered the gold standard for learning ability among experimental subjects. The octopuses seemed to understand spatial relationships, remember complex routes, and even take shortcuts that suggested they could visualize the overall structure of the maze rather than simply memorizing a sequence of turns. These early experiments opened a door that would never close. For the first time, scientists began to consider seriously the possibility that intelligence might not be limited to vertebrates, that consciousness and problem-solving ability might have evolved independently in the isolated world of cephalopods. The implications were staggering. If octopuses could think, truly think, then intelligence was far more widespread in the natural world than anyone had imagined. The breakthrough that would capture the world's attention came decades later, in the clear blue waters off the coast of northern Australia. In 2003, a team of researchers led by Julian Finn made an observation that would revolutionize our understanding of tool use in the animal kingdom. Through their underwater cameras, they witnessed wild octopuses engaged in behavior that seemed impossible for invertebrates. They were collecting, transporting, and using tools with sophistication that rivaled that of primates. The footage was extraordinary. Common octopuses were systematically gathering coconut shell halves from the seafloor, carrying them considerable distances across open sand, and then assembling them into portable shelters when needed. This wasn't opportunistic use of nearby objects, it was deliberate collection of materials for future use, requiring forward planning, spatial reasoning, and the ability to visualize how separate objects could be combined into useful structures. The process they documented revealed layers of complexity that challenged every assumption about invertebrate cognition. The octopuses carefully inspected each shell before deciding whether to invest the considerable energy required to transport it. They carried their awkward cargo by holding it beneath their bodies while walking on the tips of their arms, a method of locomotion that made them more vulnerable to predators and significantly slowed their movement. When the time came to use their collected shells, the octopuses demonstrated engineering skills that would impress any architect. The two shell halves were manipulated with precision, fitted together to create nearly perfect spheres with the octopus safely enclosed inside. The construction process required spatial intelligence, fine motor control, and an understanding of three-dimensional geometry that was breathtaking in its sophistication. This discovery forced scientists to reconsider fundamental assumptions about the evolution of intelligence. Tool use had long been considered one of the defining characteristics of advanced cognition, a capability that separated the most intelligent animals from those operating purely on instinct. The fact that octopuses, creatures separated from mammals by over 500 million years of evolution, had independently evolved such sophisticated tool use abilities, suggested that intelligence might be a more common outcome of evolutionary processes than previously believed. The revelation of octopus intelligence accelerated research efforts around the world. Jennifer Mather, working at the University of Lethbridge in Canada, began studying wild octopuses in the shallow waters of Bermuda, documenting behaviors that revealed not just intelligence but personality. Her patient observations revealed that individual octopuses showed consistent behavioral differences that could only be described as personality traits. Some individuals proved consistently bold and exploratory, investigating every new object or disturbance in their environment with apparent curiosity. These adventurous octopuses would approach unfamiliar stimuli directly, using their arms to explore strange objects and their color-changing abilities to communicate their interest or excitement. Other individuals remained consistently cautious, preferring to observe new situations from a distance before deciding how to respond. Most remarkably, these personality differences remained stable over time. An octopus that proved bold during its first encounters with researchers would maintain that boldness throughout subsequent observations, while cautious individuals continued to display careful, observational approaches to new situations. This consistency suggested individual consciousness and emotional complexity that went far beyond simple programmed responses to environmental stimuli. Mather's work also documented something that astonished the scientific community: octopus play behavior. She observed wild octopuses repeatedly releasing objects into water currents and then catching them as they drifted back, behavior that served no apparent survival function. The octopuses seemed to be playing, engaging in activities purely for the enjoyment they provided. This discovery was revolutionary. Play behavior had been observed in mammals and birds, creatures with complex social structures and extended periods of parental care that provided opportunities for learning through experimentation. But octopuses are largely solitary creatures with no parental care. Young octopuses must survive entirely on their own from the moment they hatch. The existence of play in such creatures suggested that the capacity for enjoyment, for engaging in activities purely because they are rewarding, might be far more fundamental to consciousness than anyone had imagined. Advances in underwater filming technology during the early 21st century revealed even more aspects of octopus intelligence. High-definition cameras and improved lighting systems allowed researchers to document the sophisticated social lives of creatures that had long been assumed to be entirely solitary. Male octopuses were observed performing elaborate courtship displays that could last for hours, creating moving art with their color-changing abilities, while demonstrating both physical prowess and what could only be described as aesthetic creativity. These mating displays involved coordinated changes in color, pattern, and body posture that created visual performances more complex than most human art forms. Males would approach females while displaying flowing patterns of colors that seemed to communicate not just their intentions but also their fitness and desirability as mates. Successful males appeared to be those that could create the most beautiful and complex displays, suggesting that aesthetic appreciation might play a role in octopus mate selection. The recognition of octopus intelligence led to important changes in how these creatures are treated in research and captivity. Many countries now include octopuses in animal welfare, legislation that was originally designed to protect vertebrates. Research protocols must take into account the emotional well-being of octopus subjects, and housing conditions must provide environmental enrichment that allows these intelligent creatures to express natural behaviors. Modern neuroscience has begun to unravel the biological basis of octopus cognition, revealing a nervous system so different from our own that it challenges fundamental assumptions about how consciousness arises. The distributed nature of octopus intelligence, with significant processing power located in each arm, suggests that consciousness need not be centralized in a single brain, but can emerge from networks of interconnected processing centers. Brain imaging studies have shown that octopus learning involves changes in neural connectivity that are remarkably similar to those observed in mammals. When octopuses master new tasks, their nervous systems literally rewire themselves, forming new connections between neurons in patterns that mirror the neuroplasticity observed in human brains. This suggests that the fundamental mechanisms of learning and memory may be more universal than previously believed. Recent research has revealed that octopuses possess episodic-like memory, the ability to remember not just what happened, but when and where it happened. This sophisticated form of memory was once thought to be unique to humans and a few other species, but octopuses demonstrate clear evidence of being able to recall specific events from their past and use this information to guide future behavior. The study of octopus intelligence has also revealed their remarkable ability to recognize individual humans. Octopuses in aquariums consistently respond differently to different caretakers, even after months of separation. They appear to recognize individual faces, voices, and behavioral patterns, treating familiar humans with apparent trust while remaining wary of strangers. Perhaps, most intriguingly, researchers have documented what appears to be deliberate deception in octopus behavior. Octopuses have been observed hiding food from researchers, creating false caches to mislead observers while keeping their real food stores secret. This capacity for deception requires understanding that other minds have different knowledge than one's own, a cognitive ability called theory of mind that was once thought to be unique to the most intelligent vertebrates. The ongoing study of octopus cognition continues to yield surprises that challenge our understanding of consciousness itself. These discoveries have profound implications not just for our understanding of marine life, but for our conception of intelligence, consciousness, and the nature of mind itself. As researchers around the world continue to study these remarkable creatures, each new discovery seems to reveal additional layers of complexity in octopus cognition. The journey from fear and mythology to scientific understanding has revealed creatures that may be among the most intelligent inhabitants of our planet, minds that evolved completely independently from our own, yet share with us the capacity for learning, memory, emotion, and perhaps even aesthetic appreciation. Tonight, as you drift towards sleep, consider the remarkable journey of discovery that has brought us to this new understanding. In laboratories and oceans around the world, octopuses continue to demonstrate cognitive abilities that astonish researchers and challenge our deepest assumptions about the nature of intelligence and consciousness. Their eight-armed minds carry secrets we are only beginning to uncover, mysteries that may hold keys to understanding consciousness itself. The ocean today is not the same ocean that cradled the first octopuses 500 million years ago. As our planet's climate shifts and changes with unprecedented speed, the very chemistry of seawater is transforming in ways that would have been unimaginable just decades ago. Yet in this time of uncertainty, octopuses have emerged as both sentinels of ocean health and symbols of hope, their remarkable adaptability offering lessons for all life on our changing planet. Consider the extraordinary sensitivity of these creatures to their environment. Octopuses are living barometers of ocean conditions, their success or failure in any given region reflecting the complex web of factors that determine marine ecosystem health. Their life cycles are so intimately connected to water temperature, chemistry, and food availability that changes in their populations often signal broader environmental shifts long before they become apparent through other means. The warming of our oceans poses challenges that would overwhelm less adaptable creatures. As global temperatures rise, the fundamental physics and chemistry of seawater change in cascading ways. Warmer water holds less dissolved oxygen, creating vast zones where many marine creatures cannot survive. Ocean currents that have flowed in predictable patterns for millennia begin to shift, carrying nutrients and young marine life to new destinations while leaving traditional feeding grounds barren. For octopuses, these changes represent both challenge and opportunity. Their flexible life strategies and remarkable intelligence give them advantages that more specialized creatures lack. When traditional prey species decline in one area, octopuses can learn to hunt different targets. When familiar habitats become unsuitable, they can relocate to new territories and adapt their behaviors to match new conditions. Yet even these master adapters face limits to their resilience. Ocean acidification, perhaps the most insidious consequence of increased atmospheric carbon dioxide, threatens the very foundation of marine food webs. As seawater becomes more acidic, the microscopic shell-building organisms that form the base of many marine food chains struggle to construct and maintain their protective coverings. The ripple effects travel up through every level of ocean life, eventually reaching the octopuses that depend on healthy ecosystems for their survival. The larval stages of octopus development prove particularly vulnerable to changing ocean chemistry. These tiny translucent creatures drift in the plankton for weeks or months, depending on stable conditions for their successful development into adult forms. Changes in water temperature, acidity, or nutrient levels during these critical early stages can affect entire generations of octopuses, disrupting recruitment patterns that have remained stable for millions of years. Marine biologists have begun using octopus populations as indicators of ecosystem health, much as coal miners once used canaries to detect dangerous gases. The presence of thriving octopus communities signals healthy marine environments, while declining populations often provide early warning of environmental problems that might not be detected through other monitoring methods. Dr. Sarah McAnulty, working with octopus populations in the warming waters of the Western Atlantic, has documented remarkable examples of adaptive behavior that offer hope for octopus survival in a changing world. Some populations have shifted their breeding cycles to match changing seasonal patterns, while others have expanded their ranges into previously unsuitable habitats as conditions warm. These adaptations happen with a speed that reflects the rapid generation times of most octopus species. Unlike long-lived creatures that may require decades to show evolutionary responses to environmental change, octopuses can potentially adapt to new conditions within just a few years. Their short lifespans and flexible behaviors create opportunities for rapid adjustment that longer-lived species cannot match. The intelligence that has made octopuses such successful predators may prove equally valuable in helping them navigate environmental uncertainty. Their problem-solving abilities, their capacity to learn new behaviors, and their flexibility in diet and habitat use all provide advantages in rapidly changing environments. Where more specialized creatures might fail, octopuses often find creative solutions to novel challenges. Conservation efforts for octopuses necessarily focus on protecting the complex habitats these creatures require throughout their life cycles. Coral reefs, kelp forests, rocky shorelines, and the open ocean zones where octopus larvae develop must all be safeguarded if we hope to maintain healthy octopus populations. This holistic approach to habitat protection benefits not only octopuses, but entire marine ecosystems. Marine protected areas that prohibit fishing and other extractive activities have proved particularly valuable for octopus conservation. These reserves provide refuges where octopuses can reproduce without human interference, creating source populations that can replenish surrounding areas. The complex three-dimensional structure of protected coral reefs and kelp forests provides the hiding places and hunting grounds that octopuses need to thrive. The growing recognition of octopus intelligence has led to important changes in how these creatures are treated by humans. Many countries now include octopuses in animal welfare legislation, acknowledging their capacity for suffering and their need for environmental enrichment in captivity. This recognition has important implications for research protocols, aquarium housing standards, and even fishing practices. Research into octopus cognition continues to reveal new aspects of their remarkable abilities. Recent studies have shown that octopuses can recognize individual human faces, remember complex spatial layouts for months at a time, and even engage in what appears to be deliberate teaching behavior when interacting with naive individuals. These discoveries contribute to growing recognition that intelligence takes many forms throughout the animal kingdom and that consciousness may be far more widespread than previously believed. The implications of octopus intelligence extend far beyond marine biology. Computer scientists studying artificial intelligence have begun examining octopus nervous systems for insights into distributed processing and parallel computation. The octopus model of intelligence, spread throughout the body rather than centralized in a single brain, offers alternative approaches to machine learning and robotics that could revolutionize technology. Medical researchers investigating neurodegenerative diseases have found that octopus neurons possess remarkable regenerative abilities. When injured, octopus nervous systems can rebuild damaged connections with efficiency that far exceeds anything seen in mammals. Understanding these mechanisms could lead to breakthrough treatments for conditions like spinal cord injury, stroke, and Alzheimer's disease. The study of octopus color-changing abilities has inspired new developments in materials, science, and camouflage technology. Researchers are working to create artificial materials that can change color and texture as rapidly and efficiently as octopus skin, with applications ranging from military camouflage to architectural facades that can adapt to changing light conditions. Climate change research has revealed that some octopus populations may actually benefit from certain environmental changes. Warmer waters in northern regions could create new habitat opportunities for temperate octopus species, while changes in ocean productivity patterns might favor the flexible feeding strategies that octopuses employ so successfully. The role of octopuses as both predators and prey makes them important indicators of marine food web stability. Their success reflects the health of the small creatures they hunt, as well as the larger predators that depend on them for food. Changes in octopus populations can signal shifts in ecosystem balance that affect everything from commercial fisheries to seabird breeding success. Ocean pollution poses ongoing challenges for octopus survival, but their intelligence may help them cope with human-made hazards better than many other marine creatures. Octopuses have been observed using discarded plastic containers as temporary shelters, demonstrating their ability to adapt to human-altered environments. However, this same intelligence makes them vulnerable to new threats. Their curiosity about novel objects sometimes leads them to investigate dangerous debris or chemical pollutants. The next century will test the remarkable adaptability that has made octopuses so successful for hundreds of millions of years. Their distributed intelligence, flexible behaviors, and rapid reproductive cycles provide advantages that may help them navigate the challenges of our changing planet. Yet their survival ultimately depends on our collective commitment to protecting the ocean ecosystems they call home. Marine conservation efforts increasingly recognize that protecting charismatic megafauna like whales and dolphins requires maintaining healthy populations of the smaller creatures that form the foundation of marine food webs. Octopuses, as both predators and prey, play crucial roles in these complex ecological networks. Their protection benefits entire ocean communities. Research institutions around the world continue to study octopus biology, behavior, and ecology, seeking to understand how these remarkable creatures might respond to future environmental changes. Long-term monitoring programs track population trends, breeding success, and habitat use patterns that will inform conservation strategies for decades to come. Educational programs that highlight octopus intelligence and ecological importance help build public support for marine conservation. When people understand that octopuses are not just alien curiosities but sophisticated beings with complex behaviors and important ecological roles, they become more invested in protecting ocean habitats. As we look toward the future, Octopuses represent both the challenges and the possibilities that lie ahead for marine life in our changing world. Their remarkable intelligence and adaptability offer hope that life will find ways to persist and thrive even as environmental conditions shift. Yet their dependence on healthy ocean ecosystems reminds us that the future of marine life ultimately rests in our hands. Tonight, as you drift towards sleep, imagine the millions of octopuses continuing their ancient routines in waters around the world. Each one carries within its remarkable nervous system the accumulated wisdom of 500 million years of evolution, yet each also faces an uncertain future in rapidly changing seas. Their story is our story, a reminder that intelligence, adaptability, and care for our environment will determine what kind of world we leave for future generations. In the gentle twilight of understanding, as our journey through the remarkable world of octopuses draws to its close, we find ourselves changed by what we have discovered. These 8-armed beings, swimming through their liquid realm with ancient grace, have taught us profound lessons about consciousness, adaptation, and the infinite creativity of life itself. They remind us that intelligence comes in forms we are only beginning to comprehend, and that wisdom often flows through pathways we never expected to find. Consider what we have learned about the nature of mind itself. For centuries, humans believed that consciousness required a centralized brain, that intelligence must be housed in a single command center, directing all thought and action. The octopus nervous system shatters these assumptions with elegant simplicity. Their 500 million neurons, distributed throughout their body like a living internet, demonstrate that awareness can emerge from networks of interconnected processing centers, each contributing to a unified experience of the world. This revelation extends far beyond marine biology. In research laboratories around the world, computer scientists studying artificial intelligence examine octopus neural networks for insights into distributed computing and parallel processing. The octopus model suggests that consciousness might not require a single central processor, but could emerge from the complex interactions of many simpler systems working in harmony. This understanding could revolutionize how we design thinking machines and help us create artificial intelligence that is more flexible, more resilient, and more adaptable than anything we can currently imagine. The distributed intelligence of octopuses also offers profound insights into the nature of consciousness itself. If awareness can arise from networks spread throughout a soft body, then consciousness may be far more widespread in the natural world than we ever suspected. The implications ripple outward, suggesting that intelligence might emerge wherever complex systems reach sufficient levels of organization and connectivity. Their remarkable problem-solving abilities remind us that intelligence evolved independently many times on Earth, taking forms that reflect the unique challenges and opportunities each lineage encountered. While we share common ancestors with dolphins, primates, and other intelligent vertebrates, octopuses represent a completely separate evolutionary experiment in consciousness. Their success suggests that intelligence is not an accident, not a rare cosmic fluke, but a natural outcome when life's complexity reaches certain critical thresholds. This understanding should fill us with wonder about the possibilities for consciousness throughout the universe. If intelligence could evolve independently in the isolated world of cephalopods, separated from our own lineage by over 500 million years, then perhaps consciousness represents a fundamental property of complex systems, likely to emerge wherever conditions permit sufficient organizational complexity. The octopus approach to survival offers equally important lessons for our own species. Rather than developing better weapons or stronger armor in their evolutionary arms race with predators and prey, octopuses chose a different path. They evolved flexibility, creativity, and the ability to adapt to changing circumstances with remarkable speed. Their strategy emphasizes intelligence over aggression, adaptation over domination, cooperation with their environment rather than conquest of it. This gentle philosophy of survival becomes increasingly relevant as humanity faces the challenges of a rapidly changing world. Climate change, resource depletion, and environmental degradation require solutions that emphasize adaptation and cooperation rather than simple technological domination. The octopus model suggests that flexibility and intelligence may be more valuable than raw power in navigating uncertain futures. Their mastery of camouflage offers metaphors that extend beyond simple hiding from predators. Octopuses don't just change their appearance to match their surroundings. They transform themselves to fit harmoniously into whatever environment they encounter. This ability to become part of their world, rather than separate from it, reflects a profound understanding of interconnectedness that humans are only beginning to appreciate. In our increasingly connected world, the ability to adapt to different contexts, to understand and work within diverse systems, and to find harmony rather than conflict, becomes ever more valuable. The octopus teaches us that true mastery comes not from imposing our will upon our environment, but from learning to flow with the currents and rhythms of the systems we inhabit. The emotional complexity we have discovered in octopuses challenges our assumptions about feeling and consciousness in the natural world. Their capacity for play, their individual personalities, and their apparent aesthetic appreciation during mating displays suggest that the inner lives of these creatures may be far richer than we ever imagined. They experience something analogous to curiosity, satisfaction, frustration, and perhaps even joy. This recognition carries profound ethical implications. If octopuses can suffer, if they have individual preferences and emotional needs, then our interactions with them must be guided by compassion and respect. The growing inclusion of octopuses in animal welfare legislation reflects this changing understanding and marks an important step toward a more inclusive definition of the moral community. The brief lives of most octopus species, typically lasting only 1 or 2 years, remind us of the preciousness of time and the importance of living fully in the present moment. These creatures pack remarkable experiences into their short lifespans, exploring their world with intense curiosity, solving complex problems, and engaging with their environment with an enthusiasm that never seems to diminish. Their approach to time offers lessons for our own much longer lives. While we often delay gratification, postpone experiences, and assume we will have unlimited opportunities to pursue our interests, octopuses live with an intensity that suggests every moment matters. They explore every crevice, investigate every unusual object, and approach each day as an opportunity for discovery. The mother octopus's ultimate sacrifice, guarding her eggs until death while refusing to eat, represents one of nature's most profound expressions of dedication to future generations. This behavior, observed across numerous octopus species, demonstrates that even creatures with brief lifespans can embody values that transcend individual survival. Their commitment to their offspring's success reminds us that meaning often comes not from personal achievement, but from contributing to something larger than ourselves. The research revolution that has transformed our understanding of octopus intelligence offers hope for other discoveries waiting to be made. If creatures as alien to us as octopuses can possess such sophisticated cognitive abilities, what other forms of intelligence might exist in the natural world, waiting for patient observation to reveal their secrets? The diversity of octopus species, each adapted to different environments and challenges, suggests that intelligence itself may be far more diverse than we currently understand. Marine ecosystems where octopuses thrive remind us of the interconnectedness that defines all life on Earth. These creatures exist within complex webs of relationships that span from microscopic plankton to massive whales. Their success depends not just on their individual abilities but on the health of entire ocean communities. This ecological perspective reminds us that our own survival is similarly interconnected with the well-being of countless other species and systems. The ongoing study of octopus cognition continues to yield surprises that challenge our fundamental assumptions about mind, consciousness, and intelligence. Each new discovery seems to reveal additional layers of complexity in these remarkable creatures, suggesting that we have only begun to understand the depth of their cognitive abilities. Their study may ultimately teach us as much about the nature of consciousness itself as it does about marine biology. As we look toward the future, octopuses represent both the challenges and the possibilities that lie ahead for all life on our changing planet. Their remarkable adaptability offers hope that intelligence and flexibility can help species navigate uncertain environmental conditions. Yet their dependence on healthy ocean ecosystems reminds us that even the most adaptable creatures have limits to their resilience. The lessons we have learned from our eight-armed teachers extend far beyond the boundaries of marine science. They challenge us to reconsider our assumptions about intelligence, consciousness, and our place in the natural world. They remind us that we share this planet with minds that may experience reality in ways we can barely imagine, yet who face many of the same fundamental challenges of survival, growth, and meaning that define our own existence. In the deepest sense, octopuses teach us humility. Despite our technological achievements and our growing understanding of the natural world, these creatures remind us that consciousness comes in forms we are only beginning to understand. Their alien intelligence, evolved along completely different pathways from our own, suggests that the universe may be far stranger and more wonderful than we can currently comprehend. As you drift into sleep tonight, imagine the gentle rhythm of eight-armed beings moving through moonlit waters around the world. Picture them flowing between coral formations like living poetry, their skin painting itself with colors that shift like aurora across their soft surfaces. In their graceful movements, we can see reflected the ancient wisdom of adaptation, the patient intelligence of creatures who have learned to thrive by working with their world rather than against it. These remarkable beings continue their peaceful journey through the ocean's depths, carrying forward 500 million years of evolutionary wisdom while facing an uncertain future with the same curiosity and adaptability that has served their kind since the earliest seas. In their story, we find not just scientific knowledge, but inspiration for our own journey through the challenges and wonders of existence. Their eight arms reach through the darkness of the deep, exploring, learning, adapting, and reminding us that intelligence, consciousness, and wisdom flow through our world in forms more beautiful and diverse than we ever dared imagine. In the gentle presence, we find peace, wonder, and hope for the continued flourishing of all the remarkable minds that share our planet's waters.